1 in 4 American homes has a mold problem. The industries around it pull in $6 billion per year, but a material costing under $1 per square foot has stopped mold for over 9,000 years. It's not patented. It's not new. In a 20-year European study, it produced 0 mold. The question isn't how to fix mold, it's how a crisis this profitable got built. Each year, Americans spend more than $3 billion trying to get rid of mold. The problem isn't hidden in the shadows, it's everywhere. The EPA's own data confirms that 1 in 4 homes across the United States will face mold or moisture damage during their lifetime. That's 30 million households, breathing air laced with spores that can trigger asthma, allergies, and even more severe health issues. The scale is staggering, but the mechanics are disturbingly simple. The culprit often lies within the walls themselves. Modern construction, especially since the late 20th century, relies on drywall and plastic vapor barriers to keep homes insulated and airtight. But these barriers, meant to protect, can backfire. When water vapor gets trapped behind an impermeable film, it finds nowhere to go. Moisture builds, and hidden pockets of dampness become breeding grounds for mold. Once it takes hold, remediation is expensive and rarely permanent. Joseph Lesteburek, a building scientist who has spent decades studying moisture control, sounded the alarm in the early 1990s. In a technical paper circulated among architects and code officials, he wrote, "Interior vapor barriers, as commonly installed, are the primary drivers of wall condensation and mold growth in residential construction." Lesteburek's warning was blunt. The very systems promoted as solutions were, in reality, fueling the crisis. Yet his research was largely ignored by the committees responsible for building codes. Instead, industry standards continued to double down on vapor barriers and gypsum board, locking in a cycle of moisture, mold, and costly repairs. The result is a system where failure is built in, and the price is paid by millions of families every year. In Austria, a team of building scientists set out to answer a pressing question. Could traditional wall finishes truly outperform modern construction when it comes to mold? Over 2 decades, they tracked 40 homes, half finished with lime or clay plaster, half with standard drywall and vapor barriers. The results are stark. In the group using lime and clay, not a single case of mold was found. 0. Meanwhile, 60% of the drywall homes developed visible mold within just 7 years. These were not laboratory simulations, but occupied houses, monitored year after year for moisture, air quality, and microbial growth. The cost difference did not favor the modern approach either. Material expenses for lime and clay averaged 90 cents per square foot, while drywall and vapor barrier systems came in at $1.30. The lime finish proved not only more resilient but also more affordable up front. The Austrian study did not just log surface stains or minor discoloration. Inspectors documented widespread fungal colonies in the drywall assemblies, often at the barrier seams and inside wall cavities, where trapped moisture had nowhere to go. In contrast, the lime and clay walls maintained dry, alkaline surfaces inhospitable to mold, even during periods of high humidity. For the research team, the numbers told a simple story. Where drywall and vapor barriers dominated, mold became a recurring threat. Where lime and clay plastered walls stood, the problem simply did not exist. 40 homes, 20 years, 0 mold. The evidence leaves little room for debate. Freshly mixed lime plaster starts with a chemistry that is hostile to mold at the most basic level. When hydrated lime is combined with water, the result is a thick paste with a pH of 12.8, one of the most alkaline environments found in any building material. This is not a mild effect. At pH above 12, the enzymes that fungi and bacteria depend on simply stop working. Cell membranes break down. Spores cannot germinate. for at least 48 hours after application, the surface remains above this critical threshold, forming an invisible barrier that stops mold before it can take hold. This high alkalinity is not just a fleeting phase. As the lime cures, it reacts with carbon dioxide from the air, a process called carbonation. Over days and weeks, the pH slowly drops, but the surface remains above pH 11 for a week or more, especially in thicker coats. Laboratory tests show that common household molds like Aspergillus and Penicillium cannot survive when the pH stays above 10. Even after carbonation lowers the alkalinity, the dense mineral structure of the plaster continues to resist moisture and microbial growth. The result is a protective curve, a rapid kill zone at the start, followed by a long period where the surface remains inhospitable to mold. This chemical certainty is the foundation behind lime plaster's legendary durability, and it is why structures finished in lime have stayed mold-free for centuries, even in damp climates. On the outskirts of Amman, the Neolithic settlement of Ain Ghazal rises from the earth as a silent witness to endurance. Archaeologists uncovered walls and floors finished with lime's plaster, applied more than 7,000 years ago. The surface remains almost untouched by time. No stains, no blackened corners, no trace of the mold that plagues modern homes. The chemistry that made this possible, lime's pH above 12, created a barrier that outlasted empires, preserved in the mineral shell that still lines ancient rooms. Where organic materials vanished, the plaster endured, its dense matrix locking out both moisture and decay. Centuries later, and thousands of miles away, a stone farmhouse stands in Provence, France. Built in 1690, it has sheltered generations through wars, droughts, and floods. Its owner, Marie Fournier, runs her hand along the original plaster, pointing out the absence of repairs. For 330 years, this house has never required mold remediation. No hidden leaks, no musty odor, just walls that breathe, finished in the same lime mixture known to Neolithic builders. The records show a simple pattern: routine whitewashing, never chemical treatments or costly interventions. The evidence is not locked in a laboratory or buried in statistics. It is written into the survival of these walls, structures that have resisted the one threat modern construction cannot seem to escape. In 1975, a handful of men gathered to decide what would line the walls of nearly every new American home. The International Building Code Committee, responsible for setting national standards, included not just engineers and architects, but also executives from the Gypsum Association and major insulation manufacturers. Their meeting minutes reveal a tight circle. Representatives from U.S. Gypsum, Certain Teed, and Owens Corning held key seats, while advocates for traditional lime finishes were nowhere in the room. That year, the committee voted to lock gypsum drywall and plastic vapor barriers into code, sidelining breathable wall systems. The timing was no accident. In the years leading up to that vote, the Gypsum Association reported $3.2 million in lobbying expenditures, money funneled directly into influencing code language, marketing campaigns, and industry research. The drywall market, worth $15.6 billion today, was cemented by that decision. Every sheet of gypsum board sold, every plastic barrier installed fed an industry that profits not only from the initial sale, but from the mold remediation and repair cycles that follow. The result? A system where failure guarantees future revenue, and a simple, ancient solution was written out of the rulebook. For millions of families, the cost is measured in ruined walls, medical bills, and lost trust. A single bag of hydrated lime, priced at $12, sits at the heart of this solution. Add 2 bags of clean sand, $20 for both, and a few gallons of water. That's it. For less than $40, anyone can mix a batch of lime plaster that covers 50 square feet of wall at ½ inch thick. The recipe is simple: 1 part lime to 3 parts sand by volume, stirred with enough water to make a smooth, spreadable paste. Apply it with a trowel, press it firmly, and let it set. The science is immediate. Within minutes, the surface pH soars above 12, creating a hostile environment for mold and bacteria. For the next 48 hours, the wall remains in this high alkaline state, a window where no common household mold can survive. As the plaster cures, it draws carbon dioxide from the air, slowly hardening to stone. Even after 1 week, the pH stays above 11, locking out future colonies. No plastic sheets, no synthetic biocides, no hidden costs. Just a mineral barrier that has stood the test of centuries. The cost is less than a dinner out. The effect is a wall that breathes, dries, and protects. In a weekend, any homeowner can reclaim their space from the cycle of moisture and mold. Today, millions still live in homes vulnerable to mold, while a proven $1 a bag fix sits ignored. As industry profits soar and public health costs mount, the silence around lime's effectiveness raises urgent questions. When prevention is this cheap, who really benefits from keeping the problem alive? Drop your thoughts below.